I gave a lecture on section 2.3 last week that I really thought was pretty uninspired, and I wasn't happy with my lecture, and really didn't have the class time to redo my lecture, so I thought I'd come and shoot a video so that if I completely baffled you when I did the lecture on section 2.3, that you might be able to watch this and kind of get an idea of what's going on. So this handout or this page that's sitting in front of me is available on my web page. Somewhere on my web page, towards the bottom, there's probably a link that says section 2.3 class notes. And if you print that out, it'll make it easier and have you do less writing to go through this video. There's definitely a chance that I make a mistake as I do this video. I'm sitting in a room talking to myself, and if you're watching this video and you're convinced that I made a mistake, then that could be reality, and just let me know and then specify what you think my mistake was, and I'll tell you how wrong I actually was. So section 2.3 is a section on kind of pictorially representing sets, and it introduces ways to make sets from other sets. And a lot of ums, that's a poor start. Anyways, for this section, we introduce a new concept called a universal set. And a universal set isn't a fixed set. It's fixed to a specific problem, but there isn't a magic set that's a universal set. So for a particular problem, it's the set of all the elements that we're going to concern ourselves for that problem. In another problem, we might have a different universal set. So a universal set is a set specific for a set of problems, maybe a single problem, maybe 3 or 4 problems, maybe 10 problems, but it's a specific set that contains all the elements for any set in that particular problem. When we're dealing with universal sets, we'll only deal with those elements until we move on to a different universal set. So immediately, when I call something a set, usually we give a set a name. It's usually named with a capital letter, and universal sets are usually named with the capital letter U. So anytime I see a set with the name of U next to it, I'm thinking that that's a universal set, and the elements within it are going to be the only elements I am going to consider until I see a new universal set. Universal sets can be denoted with pictures, or they can be denoted with listing a set in roster form, or you can do set builder notation, or you can do word descriptions. In this section, section 2.3, we're going to focus on listing sets via roster form that we did in section 2.2, and drawing pictures of sets. When I'm asked to draw a picture of a universal set, that picture that we draw is generally a Venn diagram. A Venn diagram is generally a picture that contains a universal set, and then any sets that are part of the universal set, any sets that are subsets of the universal set. And generally, when I create a picture of a universal set that's called a Venn diagram, I start off by drawing a rectangle. So as I look on this sheet, I see a rectangle, and anytime I see a rectangle with circles inside of it, that rectangle is going to contain all the elements of the universal set and will contain every subset of the universal set as well. This particular Venn diagram, this is a picture of the universal set U. Inside the universe, there are 2 subsets, set A and set B, and by looking at this picture, I should be able to tell all the elements that make up the universal set, all the elements that make up set A, and all the elements that make up set B. So a Venn diagram is generally a rectangular picture that represents a universal set, which is all the elements that are used for a specific problem. When I draw a universal set or a Venn diagram, I usually make a rectangle with circles inside of it. And when I do Venn diagrams, it's very customary to draw 1, 2, or 3 circles to be subsets inside of the Venn diagram. Rarely will you see a Venn diagram with more than 3 circles in it. I mean, it's not inconceivable to have more than 3 circles, but it's very unusual. So I'm going to do some of the things just to get you used to these pictures and how the pictures relate to sets. This rectangle I say is a universal set, and any number anywhere inside this circle, inside this rectangle, is an element of the universal set. And so I'm going to list the universal set in roster form, and I leave myself a lot of room here, so I'm going to write it here. I'm going to make a set bracket, is what I usually do when I'm listing a set in roster form. When I list a set in roster form, I don't have to write the elements in any sort of order. No matter if I write the elements in a random order, ascending order, or descending order, it's still the same set. It's convenient to write sets in ascending order, so I'm going to do that. So I'm going to search through my picture, and anywhere inside this rectangle, whether it's inside a circle, inside or outside a circle, any number I see is an element of the universal set. The lowest number I see is 1, so 1's going to be an element of my universal set. I see the number 2. I'm going to put a comma, and next to the 1 I'm going to write a 2. And if I quickly look through these circles or through this rectangle, I think I will see every number between 1 and 10. I won't see a number less than 1 or bigger than 10. And for this particular set, the universal set are the numbers 1 through 10. When I'm dealing with problems, with the next few problems, these are the only numbers I'm going to consider until I move on to a different universal set or a different Venn diagram, and I can't even write these right. So if you look through the universal set, I see the numbers 1 through 10. So that represents the set U for this particular picture. Within this universe, there are two subsets. There are two sets that are made up with elements only contained in the universe. To be a subset, any element in the set is an element of the bigger set. And there's two sets. There's set A and set B in this universe. And each of the sets is a subset of the universe. So B is a subset of the universe, A is a subset of the universe. Remember that this notation with the subset with a line under it allows it to be equal. This is also a true statement. It would also be true to say A is a proper subset of the universe. It would also be true to say B is a proper subset of the universe. So A and B are sets whose elements are all within the universe, so they're subsets or proper subsets of the universe. If I want to write down the elements of A, this is the A circle, and any element that's in this circle that I'm dashing out right now is going to be an element of A. And if I quickly look at it, I see there's 5 numbers in the A circle, and I'm going to write those down in ascending order. So for this particular Venn diagram in this universe, A contains the elements 1, 3, 5, 7, and 9. They're odd numbers. I did take the time to write A in order. Had I written like 9, 7, 5, 1, 3, just because that's how I just decided to write it, that wouldn't be wrong. When you're listing a set in roster form, the order of the elements not important. It's just the elements themselves. If I want to write down all the elements that make up B, anything in the circle that is next to the letter B are elements of B. And you'll notice that there's 2 elements, the elements 7 and 9, that live in both circles. The A circle and the B circle both contain the number 7 and 9. So 7 and 9 are both elements of A and B. If I wanted to list down the elements of B, and I wanted to do it in ascending order, 6 is the smallest number I see in B, so I'm going to write it first. 7 is the second smallest number I see in B, and then I see 8, 9, and 10. So the elements of B are 6, 7, 8, 9, and 10. We notice that A and B aren't subsets of each other. They're not. A is not contained in B, B is not contained in A, but A and B are definitely subsets of the universal set because every element in A is an element of the universal set. Every element in B is an element of the universal set. So this little example right here is just to get us used to the concept of a universal set and making pictures to describe sets rather than listing sets in roster form. The roster form of these sets and the pictorial Venn diagram of these sets say the exact same thing. This picture says the universe has the elements 1 through 10. Set A contains the odd numbers 1, 3, 5, 7, and 9, and B contains the numbers that are 6 or greater, 6, 7, 8, 9, 10, that are in this universe. that's all that we wanted to do for this first page, is just to start to get used to the idea of a universal set and how to form sets in roster form when you're given a Venn diagram or pictorial representation of a set. We'll see some pictures over and over again as I lecture in this section because I really don't know how to make Venn diagrams using Word. So I searched the internet and I found some examples of Venn diagrams, and we're going to see them over and over. And even when you get to your test over this section, the Venn diagrams that we see in the homework or in this little write-up of section 2.3 are going to be the Venn diagrams that you're going to see on the test. So you might as well get used to these. So here's another Venn diagram. It's a rectangle. Anytime I see a rectangle with circles inside of it, that rectangle represents a universal set. I'm asked to write down the elements of U. Again, I didn't think I gave myself enough room here, so I'm going to list the elements of the universe in roster form. And I like trying to push some sort of order on my sets, so I'm going to go from smallest to largest. I search through the circles, search through the rectangles. Any place there's a number, that number is part of my universe. The smallest number I see is 1. I now also see the number 2. I see the number 3. I see the number 4. I see the number 5. I think I'm going to see every single number between 1 and 20. I could continue listing 1, 2, 3, 4, 5 and list all the way to 20. I'm probably going to run out of room on my paper if I do that. When you're listing sets in roster form, it's not crucial to list every single element. You can use a ... as long as somebody that's looking at your set can tell the elements. So instead of writing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 all the way to 20, I wrote 1, 2, 3, 4, 5, ... 20. Usually, if I include a ... I at least show 3 items and then show my ... So had I written U equal to 1, 2, 3, ... and then 20, this would be an acceptable way to denote U. Usually you need at least 3 numbers to establish a pattern. If I just said 1, 2, ... 20, I guess I would understand that the pattern was incrementing by 1, but usually when we're using lazy notation and not listing every element, it shows 3 elements to give a pattern. So these are the numbers that make up this universe. There's 2 sets that are contained within this universe, set S and set U, and I'm going to list the elements of them. And again, I don't think I left myself room here, so I'm going to look for the S circle. The S circle is the left circle, and inside the S circle I see the numbers 1, 4, 9, and 16, and I'm going to list the elements of S. Then S are 1, 4, 9, and 16. The reason S is called S is because the numbers 1, 4, 9, and 16 are squares. 1 squared is 1 times 1. 4 is a square because it's 2 times 2. 9 is a square because it's 3 times 3. 16 is a square because it's 4 times 4. The next square is 25, which is 5 times 5, but it's outside of this universe. So 25 isn't listed in the set S. The next set I want to list the elements for is the set E. And the set E is the left circle. Anything inside the left circle, even if it's also inside the right circle, or anything inside the right circle, even if it's in the left circle, is part of the set E. So all these things that I'm circling, hopefully in orange, are part of the E set. I'm going to write E in roster form. The smallest number I see in E is 2. The second smallest number I see in E is 4. The third smallest number I see in E is 6. I see 8, 10, 12, 14, 16, 18, all the way up to 20. I could ... it now. And I'm not sure how to work my commas with the ... so I'm probably inconsistent. In this version, I didn't put commas after the before the ... but I put comma after the ... Here I put a comma before and after the ... I don't think it really matters. Maybe this is more of an English issue than it is a math issue. But I could have listed 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Or did something so that if somebody looked at my set, they understood that it represented those numbers. E for what it's worth means even, and these are all the even numbers in the universal set. The next picture we'll see over and over again has a symbol in the upper left-hand corner. I'm not sure what that symbol is, and I didn't know how to delete it, so I'm just going to cross it out right now. That somehow is supposed to represent universal set for some sort of mathematician's notation, but not mine. So same issue here. I have a picture of a universe, a Venn diagram, and any number inside this Venn diagram is part of this universe. And I'm going to try to list all the elements that make up this universe going from smallest to largest. This would be a good time if you're watching the video to hit pause, work the problem, then watch my answers. Probably the best way to watch any of my videos is to hit pause and rewind a bunch. If you get to the point where you think you know how to answer the question before I actually answer it myself, if you pause and answer it and then check yourself, that will really give you an idea of how well you are or aren't understanding material. So if you took a second right now and paused and wrote down what U is, what A are, what B, and what C are, you'll do well. This is a slightly more complicated Venn diagram because it has 3 circles in it. I'm going to have to list all the elements in the universe, all the elements that make up the sets A, B, and C that are contained in this universe. And generally when I'm writing down a universal set, I start with the universal set and then the smaller sets. To make a universal set, I start with the smallest number that I see, whether it's inside a circle or not. In this particular problem, the smallest number I see is 4. So I'm going to write it first. I see the number 5. I'm going to write it second. I see the number 6. I'm going to write it third. And I don't think there's any gaps when we go all the way up to 18. So I'll just check this real quick. So I see 4, 5, 6, 7, 8, 7, 8, 9, 10, 11, 12, 13. Yeah, so I'm going to go ... comma, and the biggest number I see is 19. So the universal set for this particular Venn diagram are all the natural numbers between 4 and 19. Hopefully it's not that much more complicated to figure out what A, B, and C are. I'm going to darken my A circle, and any number that's within this circle is going to be considered an element of the set A. And in this circle, the smallest number I see is 4. I'm listing A in roster form, writing 4 first. I see the number 6. I see the number 8. These are going to be evens again, I guess. I see the number 10. I could go ... 18, or I can list all the elements if I don't mind. I see 12, 14, 16, and 18. So that's without a ... but if you did a ... that would be fine. That's all the elements of set A. Now I'm going to darken the B circle so I know what I'm looking at when I'm trying to represent the B in roster form. So any number that's within this orange circle, even if it's already in set A, needs to be part of my universe. In the B circle, I see the number 6. So I'm going to write it first. Then I see this next smallest number was 9. And then I see 12, 15, and 18. Those are all multiples of 3 for what it's worth. A has the even numbers between 4 and 19 inclusive. B has the multiples of 3 in the universal set. And then I'll do set C. Set C is this set in the bottom. And any number, whether I've listed it in a few other sets or nowhere else, anywhere in this dark blue circle needs to be any number in this dark blue circle needs to be considered part of C. When I list C in roster form, the smallest number I see is 5. I see 6, I see 10, and I see 15. I don't really see any pattern to describe what C is, so I can't say it's multiples of 3 or even numbers. It's just, I don't know what it is. It doesn't have any special designation to me. But that's anyways, this is how we're going to go from a Venn diagram to understand the sets that are within that universe. When we start studying sets in this section, we're going to make new sets from sets that exist in the universe. And most every problem that we do for the rest of this lecture can be done with or without a picture. So this is a matter of preference and a matter of where your comfort level is, whether you solve the problems pictorially or you solve the problems pretending that the picture didn't exist. So I'll try to do the problems both two ways. Ultimately, whichever way you're more comfortable with is the way that you should do. The methods that I use will take me to the same answer. The first new word that we get in this section after, well, the second word after universal set is complement. And a complement of a set is given by that notation. So I read that symbol as a complement. You might hear me just accidentally say A prime. So when I see that symbol, I might interchangeably use the words A complement and A prime. What that symbol represents is every element in the universe that's not in the set A. So A prime is a set of all the elements in the universe that's not in set A. So we worked with these sets before. This set right here, the universe, if you look back in your notes, contained the numbers 1 through 10. We listed what set A was in this set. A was the odds. It was 1, 3, 5, 7, and 9. The instructions for this particular picture at this point ask me to find A prime. There's two ways to find A prime, either using the picture or not using the picture. I'll do the non-picture approach. A prime, or A complement, would be all the elements in the universe that aren't in set A. A way to do it if you don't have a picture is to list your universal set, list the set that you're taking the complement of, and then cross out the elements that are in the set that we're working with. If I want to find A prime or A complement, what I'm going to do is I'm going to cross out any number in the universal set that's in the set that I'm finding the complement of. So A are the elements 1, 3, 5, 7, and 9. The universe for this problem is 1, 2, 4, 6, 8, and 10. A prime would be the numbers 2, 4, 6, 8, and 10. They're any number that's in the universe that isn't in the set that I'm dealing with. So it's the rest of the universe. A contains the odds. The prime of A, or the complement of A, is going to contain the evens. If you're a picture person, A prime consists of any number outside the A circle. So the answer to what is A prime or what is A complement, it's the set 2, 4, 6, 8, and 10. I could get that without looking at a picture at all if I knew what sets A and U were. I didn't even need to know what set B was to answer this question. Whether an element is in B or not has nothing to do with whether it's in the complement of A. Pictorially, the complement of A is any part of the universe that's outside the A circle. So what I normally do when I'm making pictures to figure out what a set is I draw my picture and I shade, and the area that I shade is the area that it's going to contain the elements I want. The elements that I want are anything that's in the universe outside the A circle, and these numbers, those 5 numbers are outside the A circle. The numbers 1, 3, 5, 7, and 9 are inside the A circle. 7 and 9 are also inside the B circle. But when I'm trying to find A complement, I'm trying to find any number that's outside the A circle. So I darken the A circle and I search for on the outside of the A circle. And the outside of the A circle, I see the numbers 2, 4, 6, 8, and 10. And pictorially, that's a way to figure out what the complement was without having to do crossing out of a universal set. So the answer to find A prime or A complement is the set 2, 4, 6, 8, and 10. Same sort of issue here. I ask you to find E complement for the set E. If I wanted to do this without looking at the picture, I'd have to write down what the set E and U are. We did this already, so I'll quickly do them. The universe for this particular problem were the numbers 1 through 20. And if I'm going to find a complement without looking at a picture, then I can't have the dot, dot, dots in my picture. And this is going to be a nuisance to write, but it's not impossible. So the universe for this particular problem are the numbers 1 through 20. And when we found E was this circle here. E contained all the evens. So E contains the numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. We already did this when we entered on the previous page. In order to find E complement, if I wasn't looking at the picture and I had both E and U, what I'm going to do is cross out all the elements. I forgot to write 7 in here. Sorry. I'm going to cross out all the elements in the universe that are in set E. So E contained 2, 4, 6, 8, 10, all the evens all the way up to 20. In my universe, I crossed out all those numbers. The numbers that are left are the complement of E. So the complement of E, since E was the even set, the complement is going to be the odd set. I'm writing E prime, probably writing O would have been nicer. But I can tell that E and E prime are related with this notation. And the elements that are going to make up E prime are 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. That's the answer. I got that answer without looking at the picture after I had these sets constructed. If I wanted to get the complement of E from the picture without having to go through listing and crossing out, I'd go to my picture, I'd isolate the E, and then I'm searching outside of E. So any number that's written outside the E circle is a number that belongs in the complement. So the numbers that belong in the E complement list are any number that's outside the E circle. And if you look at the numbers that I just circled, they are the numbers 1, 3, 5, 7, 9, 11, 13, 15, and 17. So all the numbers outside the E circle. You notice that the number 4 and 16 I didn't include in E prime, even though they're in both the S and the E circle because they're a square and they're even. The S has nothing to do with this particular question. In this question, I'm only looking at inside of E and outside of E, inside the universe, but the S really has nothing to do with my work. So hopefully this is going moderately okay. Next thing I need to do is answer the same sort of question for the third Venn diagram that had the 3 sets. I want to find C prime for the set C. If I'm doing this without the picture, I at least have to use the picture to get the universal set. We picked up this universal set before. It had the numbers 4 through 19. So I'm going to write those down. And I have to write them all down if I'm trying to find the complement without using my picture. So the universe for this problem contained any number between 4 and 19. Set C contained the numbers 5, 6, 10, and 15. If I want to write down what C complement is, then from my set U, I cross out the 5, 6, 10, and 15. So I cross out the 5, I cross out the 6, I cross out the 10, I cross out the 15. Anything that's left makes up C complement. So what's left is 4, 7, 8, 9, 11, 12, 13, 14, 16, 17, 18, and 19. That would be C complement without really looking at the picture to figure out what the complement was. You can always, if you're asked to find a complement, list the universe, list the set that you want to find the complement of, cross out the elements that are in the set, in the universal set that's in the set that you're starting with, and that will give you the complement. If I wanted to find the complement without doing the listing, the complement of C is any number that's outside the C circle. And again, I'm not worried about whether a number is in the A or the B circle. So outside the C circle, the smallest number I see is 4. 5's in the C circle, C's in the C circle. 5 and 6 are. 7 isn't, 8 isn't, 9 isn't, 10 is, and 11 isn't, 12 isn't, 13 isn't, 14 isn't, 15 is, 16 isn't, 17 isn't, 18 isn't, and 19 isn't. So those numbers that I circled in orange are outside, they're in the universe, but outside the C circle, so they need to be part of my universe. When I get back to my office, I'm going to fix problem 16. Problem 16 asks me to make a Venn diagram, and I think I sold the universal set short. Let me quickly look at this, because when I did it in class, I remember running into issues in that some of the sets contained elements that weren't in my universe, and that's a bad thing. Let me see. Microwave, washing machine, dishwasher. I didn't have computer in the universe, so the universe also has to have computer in it. And hopefully by the time you're doing this, I added this. TV's there, washing machine, dryer, refrigerator, CD player, computer. I should have probably made this television TV because to be consistent. Let me double check this again. So microwave is there, washing machine, dishwasher, didn't have computer, TV, washing machine, dryer, refrigerator, CD player, computer. So what the author wants us to do, so this is actually a problem from us from the book, and the author wants us to have the ability to create our own Venn diagrams. And I create a Venn diagram by first making a rectangle. They represent the universal set. And inside the universal set, I make circles, overlapping circles for any set that's contained within the universe. And in this universe, there's two sets, A and B. So I'm just going to draw two circles, and I'm going to make them overlap. And I'm going to put an A next to the left circle, a B next to the right circle, because that's the common way to do it. And now I'm going to list all the elements of the universe so that I can tell which set that they're in. When you're doing this, usually we do the overlapping region of the circles first. The overlapping region contains any element that's in both the A and the B set. And if I look at the A and the B set, what they have in common are a washing machine, a computer, a TV, and I think that's all they have in common. There's just no way I'm going to be able to write washing machine, computer, and TV very well, so I'm going to give letters. I'm going to write W for washing machine. I'm going to write, how about CU for computer, and TV for TV. So in this world, this universe, I'm going to write a W for washing machine. It's in the universe, so it's in the rectangle. It's in set A, so it's in the A circle. It's in set B, so it's in the B circle. This region right here is the region of the Venn diagram that's in the universe, it's in the A, and it's in the B circle. So I've got the washing machine placed perfectly. Now I'm going to place the computer in the same little region, because the computer, it's in the universe, so it's somewhere in the rectangle. It's in the A circle, so it has to be somewhere in the A circle. It's in the B circle, it has to be somewhere in the B circle. This region where the A and the B circles overlap is exactly the place that those belong. So I'm going to cross out the computer that I just put in, and now I'm going to put the TV in the same locale. So TV, TV, and TV. So now I've placed some of the items in my universe. I'm going to start filling up the rest of my sets. I'm going to fill up the rest of my set. I go backwards when I do this. I'm going to fill up the rest of my set B. B needs to have a dryer in set B. It's not going to be in this middle region, because in this middle region, it's also overlapping set A. So I'm going to put dryer, and I'm going to label that DR. And I'm going to put it in the right half of the B circle. It has to be in the rectangle because it's in the universe. It has to be inside the B circle, but it can't be in the overlapping part because it's not in the A circle. I'm going to now put the refrigerator and the CD player in the same regions, because this region, I'll use R for refrigerator, and I'm going to use CD for CD player. So what I've placed is all the elements of B. I've placed the elements of A that are also in B. Now I'm going to replace the rest of A. The dishwasher and the microwave need to go in the A circle, but they can't go in the overlapping part because they're not also in the B circle. And for microwave, I guess I could just use an M, and I guess I could use a D for dishwasher. It'd probably be nicer if I wrote all these words out, but I didn't give myself a lot of room to do that. So I'm going to place the microwave in the dishwasher. M for microwave, D for dishwasher. If you wanted to, dish maybe would be better. Now I'm going to cross those elements out. I've placed the microwave and the dishwasher where they belong. The microwave and the dishwasher in the universe, so they have to be in the rectangle. They need to be in the A circle, but they can't be in the overlapping part of the A and the B circle because they're not in B. So now I've placed all the elements of B. I've placed all the elements of A. I still have two more elements. I have a camcorder and a VCR, and I'm going to put those in the, they have to be in the rectangle. They can't be in any of the circles because they're not in the A or the B. And I don't have a C to worry about here, so I'm going to put the camcorder. I probably could have just abbreviated that, but I kind of thought I could fit it. And I'm going to put the VCR. You can start to see the age of this book because camcorders and VCRs and CD players are things that are dying. I'm going to cross out the camcorder and the VCR because I've placed them already. So we have the ability, if I'm given sets in roster form, to create our own Venn diagram. And that's what problems 15 through 18 in section 2.3 in the book ask us to do. Anytime I'm asked to create my own Venn diagram from a set that's listed in roster form, I do that same structure. I fill in the overlapping elements of the sets, then I fill in the rest of the sets. I'm crossing out as I'm filling in my Venn diagrams, and then after I've completed all of my sets, anything else that's in the universe is outside the circle but still inside the rectangle. This skill gets going to be important because it comes up again in sections 2.4 and 2.5. So far we've looked at Venn diagrams that give us pictorial representations of sets. We can use Venn diagrams to create roster form lists of elements of sets. I could find the complement of a set. The complement of a set is any element that's not in the set that's in the universe. And now we're going to get to a new concept, and it's a friendly concept, the concept of intersection. The intersection usually involves multiple sets that are inside the universe. The intersection of two sets in a universe is given by this symbol. So this symbol, when I see it, I try to say the word intersection. And intersection, sometimes you'll hear me say the word and. Intersection and are kind of mathematically equivalent when we're dealing with sets. And the intersection of sets are the elements that are in common. So for this particular Venn diagram, if I want to find A intersection B, I can do it without my picture, I can do it with my picture. To do an intersection, it's probably nice to know what the universe is, but it's not always crucial. In this particular set, this Venn diagram, we've done this Venn diagram already. The universe has the elements from 1 through 10. A contains the odds, 1, 3, 5, 7, and 9. It probably wouldn't hurt just to have all the Venn diagrams just kind of at your fingertips so you don't have to keep creating the elements. So anyways, this problem asks me to find A intersection B. When you intersect two sets, you form another set. And for this particular problem, the elements that go in A intersection B are any elements that are in both sets. If I'm not looking at my picture, I look at my lists, and the elements that the sets have in common are the elements that make up the intersection. And so for A intersection B, the only elements that they have in common are 7 and 9, so I gave myself way too much room here. A intersection B equals 7 and 9. Just the set containing 7 and 9. Pictorially, if I didn't want to take the time to write down my universe, my set A and my set B, I can still find what A intersection B contains if I know the region of the graph that's being looked for here. If I look at my picture, I have an A circle and I have a B circle. And if you notice, those circles intersect. The A and the B circle exist simultaneously in this middle region right here. That region, the region where the two circles intersect, is the region A intersect B. So intersecting is where graphs overlap. The graph of A and the graph of B overlap, and inside the overlapping are the numbers 7 and 9. Similarly, if I looked at this graph and I wanted to find S intersection E, I could do it with my picture, or I can do it without my picture if I had the sets written down. When I'm finding intersections and I'm not having the complements thrown in, if I'm trying to find my intersection without the picture, if I just had the sets listed down, I don't really need the universe. So set S is the sets 1, 4, 9, and 16. Set E is the set 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. If I'm asked to find S intersection E, even if I didn't have a picture, I could find it quickly. I look at the set S and the set E and look to see what they have in common. They both have the number 4, and they both have the number 16. The numbers that the sets have in common make the intersection of the sets. So S intersection E is the numbers 4 and 16. Pictorially, the intersection is the same region. Even though I have different names for my sets, the intersection region is going to be this middle section right here. This middle section, it's part of the S circle, and it's part of the E circle. And the numbers in the middle there, 4 and 16, are the elements that make up S intersection E. So when we get to the test, different students will have different comfort levels in terms of how they're able to find intersections and complements. You can do them without completely ignoring the picture if you have the sets listed in roster form, or you don't really even need the sets listed in roster form if you understand the region of the graph that contains the intersection. So the intersection of two sets is generally the middle region if I'm not having complements thrown in. There's only one right answer. A intersection B is the set containing 7 and 9. S intersection E is the set containing 4 and 16. Whether you list the sets in roster form and find out what they have in common, or identify the region of the graph where the intersection exists and the elements inside that intersection, it doesn't matter to me. For me, intersections are really easy to get via graphs, so I usually don't do the roster form. But the problems will start to get more complicated because we're going to throw different operations together. We're going to put complements and intersections together, and sometimes it gets harder to understand what region of the graph that we're looking for, whereas looking at the sets in roster form, even though it might seem cumbersome, it doesn't get as tricky. In this particular problem, I ask you to do another intersection, B intersection C. And I really, if I'm not dealing with complements, I don't really need to have the universe written down to find my intersection. If we went back to this particular set, when we created it, B had the multiples of 3, had 6, 9, 12, 15, and 18. C had the numbers 5, 6, 10, and 15. If I want to find B intersection C, I just look at my list. Both B and C have the number 6 in them. Both B and C have the numbers 15 in them. And that's the only numbers I see in common. So B intersection C is a set that contains the numbers 6 and 15. Pictorially, it's slightly more complicated when you have 3 circles. But if I isolate the C circle, draw a circle around it, and isolate the B circle, draw a circle around it, the regions where those 2 circles overlap, which is this region here in the middle between the 2 circles, it contains the intersection of the numbers 6 and 15. The next few problems are going to be harder to do via pictures, probably easier to do via the set and listed in roster form. You notice I start throwing some complements down here. So when I start this problem, I'm going to go real quickly. I'm going to list any set that's I see depicted in one of my questions. So in my questions, I see an A, I see a B prime. I do see a B as well, even though it's in a parentheses. I'm going to list down what each of the sets is. We've done this already, so if you flip back in your notes, you can probably list what makes the sets up. It wouldn't be bad practice if you've forgotten how to create these sets, if you pause the video for a little bit and wrote down what makes up A prime, B, and B prime, and then check. So if you pause and go at it, it would be great. A contains anything in the A circle. It's 1, 3, 5, 7, and 9. So I'm being a little slicker here. A prime consists of anything that's not in the A circle. So the A circle was the numbers 1, 3, 5, 7, and 9. I've covered up all the numbers in the A circle. What's left are the numbers in the A prime, which are 2, 4, 6, 8, and 10. So I'm just going to list these sets down because they're going to help me answer the questions if I'm not good at looking at pictures. B contains the numbers 6, 7, 8, 9, and 10. And we've done this already. Hopefully you understand how to construct these sets. And if I cross out all the parts of B, what's left, 1, 2, 3, 4, and 5, would make up B prime. So in this particular universe that contains the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, I can construct easily the sets A and B because A consists of anything in the A circle, B consists of anything in the B circle, and then the complement for each set is anything outside its circle. So outside the B circle, the numbers 1, 2, 3, 4, and 5 are B complement. Outside the A circle, the numbers 2, 4, 6, 8, and 10 are A complement. So one thing I'm asked to do here is A intersection B complement. To do that with my sets, I'll just write the sets I'm intersecting. A is the set 1, 3, 5, 7, and 9. B complement is the set 1, 2, 3, 4, and 5. And if I want to intersect those 2 sets, I see what they have in common. I see a 1s in both sets. I see a 3s in both sets. And I see a 5s in both sets. So A intersection B complement is the numbers 1, 3, and 5. I'm going to do all of these with symbols, and then I'll show you how to do the pictures. I'll do the pictures on a different sheet of paper because it's maybe slightly more complicated. The next thing I'm asked to do is A prime intersection B prime. To do A prime intersection B prime, I can just write down what the set A prime is. A prime is the set 2, 4, 6, 8, and 10. I write my intersection symbol, and in place of B prime, I write what it is. It's the set 1, 2, 3, 4, and 5. When I intersect these sets, I find out what they have in common. Both sets have a 2. Both sets have a 4. And if I'm not mistaken, that's the only thing they have in common. So the answer to what is A prime intersection B prime, it's just the numbers 2 and 4. So I'm not using my pictures at all. I used my pictures to figure out what the 4 sets were in this problem, but I didn't do anything else, and I got my answer that I needed without having to look at the Venn diagram, which can be a little tricky if you're not very visual. The third problem wants me to do A intersection B prime. And to do A intersection B prime, I have to do the parentheses first. The parentheses is A intersection B, and then I'll do the prime. So I'm going to do the set 1, 3, 5, 7, and 9, which is A, intersection B, which is the set 6, 7, 8, 9, and 10, and then I'll do the prime. So when I intersect these sets, I see a 7 and a 9. So A intersection B by itself is the set that contains the numbers 7 and 9. Now I want to do the prime. The prime of a set is the universe taking out those sets. So the universe for this particular problem is the numbers 1 through 10. If I want to do a prime of that set 7, 9 prime, what I'm going to do is list the universe and cross out those numbers. So I'm crossing out 7 and 9. When I cross out the numbers, that's what the prime is. So the prime for 7, 9, which is A intersection B, is 1, 2, 3, 4, 5, 6, 8, and 10. So to do A intersection B prime, not looking at my pictures, I get the numbers 1, 2, 3, 4, 5, 6, 8, and 10. I'm not terribly gifted visually, and for me, it's easier to answer these types of questions just by writing down each set and doing the operations that I'm asked to do. If you're visually gifted, then not even having the sets listed out and answering the questions by just understanding the regions that I'm looking for is a really good way to go. So I'll try to do each one of these 3 problems again, just focusing on pictures, and my answers are going to be the same. So you need to, once I'll do the problems 2 ways. When we get to the test, you'll only have to do the problem 1 way, whichever way you decide the better way for you. So in this particular world, we have a universe, and inside the universe, we have a set A and a set B. And I'm not even going to throw the numbers in. I'll use my picture for the numbers in a second here. So the first thing I was asked to compute was A intersection B prime. And to do that, I have to figure out where those regions overlap. A is anything inside this A circle. So this represents all my entire A world. B prime represents anything outside the B circle. So I'm going to draw the B circle, and I'm going to go outside the B circle. So outside my B circle is this region. Intersection is where the regions overlap. So I want the inside of the A circle to overlap with the outside of the B circle. And this is this region right here. This region is simultaneously inside the A circle and outside the B circle. And any elements that are in that particular region are the elements that are going to be found in A intersection B prime. When I go back to my picture, these 3 numbers right here, they're inside the A circle and outside the B circle. This is what this means. It means inside A and outside of B, and that's the numbers 1, 3, and 5. If I look at my answer 1, 3, and 5, if I look at the numbers in this region that are inside the A circle but outside the B circle, I see the numbers 1, 3, and 5. So the answer to this is just the numbers 1, 3, and 5. Whether you get it by identifying the area of the picture that needs to be focused on and then figuring out which numbers exist in that area, or if you ignore the picture and do just using the sets like I did, both will work. The next problem, or the next part that we did, was A prime intersection B prime. And A prime means outside the A circle, B prime means outside the B circle. To figure out the numbers that I'm looking for, I figure out the area that's simultaneously outside the A circle and outside the B circle. To go outside the A circle, it's going to be anything outside the A circle, whether it's in the B circle or not. That whole region that I put in a lighter blue is outside the A circle. If I want to find the region of the graph that's outside the B circle, I look outside the B circle. And now I see what area is both simultaneously outside the A circle and outside the B circle. And that's going to be this region out here. This is where that I'm simultaneously outside the A circle and outside the B circle. And if I look at the numbers in my Venn diagram, the numbers that are simultaneously outside the A circle and outside the B circle are the numbers 2 and 4. And A prime intersection B prime is the numbers 2, 4. So the answer to this, whether I'm figuring out the region of the graph that I need to look at and not listing out my elements of my sets, or if I'm just listing the sets and doing what the operations tells me to do, lead to the same answer. I'm more inclined to do this strategy because for me, I'm not that visual and it's not that hard. I can figure out what those sets are easy. It's not hard for me to figure A prime, B, and B prime. And then intersecting, I just write the sets I'm intersecting. Here I was intersecting A and B prime. So I wrote down the contents of A. I wrote down the contents of B prime. I intersected them to see what they had in common. So it's just your level of comfort and how gifted visually you are. Some people are way more visually gifted than I am, and they can run through these questions instantaneously without really any thought. And that's a beautiful gift if you have it. If you don't have it, these problems are totally doable, without looking at the pictures. The last thing I was asked to deal with is this A intersection B prime. And for those of you that are visually gifted, A intersection B is that region. To find the prime of A intersection B, it's anything that's outside of that region. This is the region. Anything that's outside of the A intersection B world. So any number that's not in A intersection B is part of A intersection B prime. So it represents anything that I'm drawing here deeply in blue. Anything that's not part of A, anything but that little section right there. So any number that's outside that section, because this is asking me to find the complement of A intersection B, that means everything that's not in A intersection B. A intersection B contains the number 7s and 9. So A intersection B prime contains anything outside of that intersection. So 1, 3, 5 over here, the 2 and 4 down there, and the 6, 8, and 10. So anything but 7 and 9. If you look at my list here, I wrote 1, 2, 3, 4, 5, 6. I didn't write 7. I wrote 8. Didn't write 9. I wrote 10. So 1, 2, 3, 4, 5, 6, 8, and 10 are what A intersection B prime is. So you need to get your comfort level. If looking at the pictures and figuring out the answers to the questions by just looking at the pictures and understanding the area that needed to be focused on, it works for you, then that's a beautiful thing to do. If that didn't work for you, hopefully this strategy works for you, just listing what the sets are, and if you ask to intersection is what they have in common. There's a handful more of intersection problems that we're going to do. I'm going to keep doing them both two ways, and then you need to decide for you which way you want to go. And there isn't a right nor wrong or a best nor worst way to do. It's just for your level of comfort what makes the most sense. So I'm going to write down all the sets that might be appropriate for this problem, which are S, S prime, E, and E prime. Hopefully, you can pause the video and write down what elements make up those sets. And I'll do that real quickly. The universe is the numbers from 1 through 20. S contains the squares, which are 1, 4, 9, and 16. Throw those numbers out of the universe. So take the numbers 1, 4, 9, and 16 out of the numbers from 1 through 20. So we skip 1, we have 2, 3, we skip 4, we have 5, 6, 7, and 8. We skip 9, we have 10, 11, 12, this is a nuisance, 13, 14, 15, we skip 16, we have 17, 18, 19, and 20. So S prime are all the numbers in the universe that aren't in S. The universe has the numbers 1 through 20. So if I take the numbers 1 through 20 out of the universe, I'm left with 2, 3, skip 4, 5, 6, 7, 8, skip 9, 10, 11, 12, 13, 14, 15, skipping 16, then 17, 18, 19, 20. E, if I did this again, this was the evens. It's 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And then E prime is anything in the universe, any numbers between 1 and 20 that I haven't already listed. I've listed all the evens. E prime is anything outside the E circle. It's the odds. And I'm going quickly because this is going to be a 2-hour video anyways, and hopefully you can discover what each of these regions or each of these sets contains quickly. If I did a sucky job, come visit me and I'll try to explain better. So this strategy, writing out all the sets that might be relevant to a specific problem, is only something I'm doing if I'm trying to answer the questions without using the pictures. If you're visually gifted and can get the answers using the pictures, then you don't have to write these down. But for me, I'm not that visually gifted, so I'll do it this way. So first question, what is S intersection E prime? Well, I'm going to write the S set down. S is the set 1, 4, 9, and 16. I'm going to write my intersection symbol, and I'm going to write for E prime, I'm going to write 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. To intersection these is what they have in common. I see a 1 and a 1. I see a 4. I don't see a 4. I kind of crudded out there. I see a 9 though. So 4 is not part of it, but 9 is. So this 4 that I tried to circle out was a screw up. The only numbers in the intersection, the answer to what S intersection E prime is the numbers 1 and 9. So the answer to what S intersection E prime are the numbers 1 and 9. Next one, E prime intersection S prime. I'm just going to write what each set is. Oh, and I would not have room for this so well. E prime is the set 1, 3, 5, 7 all the way up to 19. So E prime contains 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. I'm going to do this in a lower spot. And S prime I'm going to write under because I just don't have room to write it off to the side. S prime is 2, 3, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now what these sets have in common make E prime intersection S prime. So I'm going to write my answer. E prime intersection S prime equals, and what do they have in common? I see a 3 here and a 3 there, a 5 and a 5, a 7 and a 7. I see a 9 there but not a 9 there. 11 I see a 13 in both. I see a 15 in both. I see a 17 and a 19 in both. So it's a big set. E prime intersection S prime. When I write the E prime set down and I write the S prime set down, it's anything that's simultaneously in both sets. The numbers that are simultaneously in both sets. So E prime intersection S prime would be 3, 5, 7, 11, 13, 15, 17, and 19. The next part, I'm just going to throw in a different sheet of paper. I'm going to do E intersection S prime. So first I'll do E intersection S, and then I'll do the prime. So to do E intersection S prime, the first thing I'm going to do is I'm going to do E, which is 2, 4, 6, 8, 10, 12, 14, 16, 18. So that's E. And I'm intersecting this with 1, 4, 9, and 16. When I form that intersection, what these sets have in common is they both have 4 in them, and they both have 16 in them. So E intersection S is the set that contains 4 and 16. I want to do the prime of this set. So I've done the E intersection S. Now I want to do the prime. To do a prime, the prime of a set is all the numbers in the universe that aren't part of that set. The universe contains the numbers 1 through 20 in this particular problem. So the universe has 1, 2, 3, 4, 5, 15, 16, 17, 18, 19, and 20. To do the prime, I'm going to cross the numbers out that are in the set that I'm priming, and everything left is part of the prime. So E intersection S prime are going to be all the numbers in the universe other than 4 and 16. So they're going to be the numbers 1, 2, 3, not including 4, I crossed it out, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, not 16, I crossed it out, 17, 18, 19, and 20. So that's the answer to that. So each one of these answers can be obtained without listing the sets in roster form if you understand the region of the picture that we're looking for. And that's just a matter of having a gift or not having the gift. The more you do this, the better, the more possible it is to have that gift. So now I'm going to redo each of the 3 problems, S intersection E prime intersection S prime, and E intersection S prime, just looking at my pictures and not listing the sets in roster form and seeing if I could obtain the same answers by understanding the regions that the graph is asking me to find. So my graph has has a nice picture that has an S and an E, and these things are filled up, but I don't need to fill them up to understand regions. The first thing I'm looking at is S intersection E prime. That means inside the S circle, outside the E circle. So I'm looking for this. S means inside S, and E prime means outside E. The region of the graph that's simultaneously inside the S circle and outside the E circle is this region here. And there's other ways to explain that, but that doesn't seem so bad to me. So if I understand what this is saying, inside the S and outside the E, if I consider prime as outside the circle, non-prime inside the circle, inside the S, outside the E, that's that region there. If I go to my graph, the numbers in that region that are inside the S and outside the E are the numbers 1 and 9, and S intersection E prime is going to be just the numbers 1 and 9. So I could write that down, and I'm done with that. It's easy pictorially if you understand what region you're shooting for. When you do things non-pictorially using the lists, it's easier to give partial credit. When you pick the picture apart, and if you get the wrong region, it's hard to give a lot of partial credit. This next E prime intersection S prime, I read this as outside of the E and outside of the S. The region that's simultaneously outside the E circle and outside the S circle is this region out there. That's the region of the graph that's simultaneously outside both circles. If I look at the numbers that are simultaneously outside both circles, I see 3, 5, 7, 11, 13, 15, 17, and 19. And when I wrote this here, I got 3, 5, 7, 11, 13, 15, 17, and 19. There's no difference in terms of a final answer, by analyzing and understanding the region of the picture that you need the elements from, as listing out the sets in roster form and doing the operations that are asked for. So it's completely a matter of preference. You might from time to time do a mix. Some problems might be so easy to figure out the region of the picture that you'll use the picture strategy, and then some problems understanding the region of the picture that I want might be hard, and you might go to the listing strategy. So you might use a blending of both. You might just do all the listing strategy. You might do all the picture strategy. It's just a matter of your personal comfort level. But the answers aren't going to be different. So when you're attacking a problem that has a Venn diagram and it asks me to do intersections and complements, or intersections and primes, I use primes and complement interchangeably, your answers aren't going to be different if you pick a method that's different than I pick. The last problem pictorially wants me to find E intersection S and then the outside of that. So for this particular problem, we have the S circle, we have the E circle, the S intersection E or E intersection S, that's where they overlap. But I want the complement or outside the overlapping of E intersection E. So what I'm looking for in this problem is anything outside the intersection, and that's anything that's in the non-overlapping part of the circles, either outside the circle or in the non-overlapping part of the circles. So it's going to contain these numbers that are inside the circle but not in the overlapping part of the circle, and all these numbers that are completely outside the circles, because E intersection S is this region where inside the circles where the circles overlap. I want the complement of that. I want everything that's not in that region, which is everything that I listed there, and it's this horribly long list of numbers. It's everything but 4 and 16. So it's the numbers 1, 2, 3. I'm excluding 4, so I'm not going to write 4, and I'm not going to write 16. So it's 1, 2, 3, and then 5, 6, 7, 8. I probably could do this with a dot, 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 but I'm not going to. But if I could understand what you're searching for, then that's okay. I think I went up to 20. So if I compare my answers, I shouldn't have any difference in my answers that I did. When I did E intersection S prime, I see everything but 4 and 16, and that's everything outside that region. There's no difference between answering Venn diagram questions with or without the pictures. They all lead us to the same result. So again, hopefully you're using the pause feature and answering questions before I answer them, because if you could do that, then you really understand. Next picture, again, this little symbol, I don't know how to get rid of it. It's just there, and you have to deal with it. I just cross it out. I'm going to write down all the sets that I need here. The numbers, again, the universe have the numbers from 4 through 19. We've done the universe before. A is the evens in the universe. It's 4, 6, 8, 10, 12, 14, 16, and 18. A prime is anything in the universe that's not in the A circle. The universe is the numbers 4 through 19. A is the evens. A prime is going to be the odds. So any number that's in the universe that's not in A makes up A prime. And again, when I'm answering the questions without looking at the pictures, it helps tremendously if I write down what each set and its complement is. B is 6, 9, 12, 15, and 18. B prime is going to be long. B prime are all the numbers between 4 and 19 except those numbers. So I'm going to write B prime. The smallest number that I see in the universe is 4. 5's in the universe. I'm not going to use 6 because it's already in B. 7 and 8 are in the universe. 9's in the universe was in B. I'm not going to write it. 10 and 11 I'm going to write. 12 I'm not going to write. 13 and 14 I'm going to write. I'm not going to write 15. I'm going to write 16 and 17. I'm not going to write 18. I'm going to write 19. So B prime are all the numbers between 4 and 19 that I haven't already included. So I've already, B has 6, 9, 12. If I put B and B prime together, I get the whole universe. And then C is this baby small set. It just has the numbers 5, 6, 10, and 15. And then C prime is all the numbers 4 through 19, but those numbers. So I'm going to include 4. I'm not going to include 5 and 6. I'm going to have 7, 8, 9. I'm not going to include 10. I'll have 11, 12, 13, 14. I'm not going to include 15. And then 16, 17, 18, and 19. So for any question that I could ask you, making primes and intersections for the sets A, B, and C can't involve any sets other than A prime, B prime, and C prime. First one I want to do is A intersection B prime, which is very long, so I'm going to maybe put it on a different sheet of paper. To do A intersection B prime, I write the A set down, which is 4, 6, 8, 10, 12, 14, 16, and 18. I write the B prime. I can't write it to the next of it, so I write it under. Intersection B prime, and B prime is 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and 19. To do A intersection B prime, it's what these two sets have in common. They both have the number 4, so that's going to be part of my intersection. Oh, they both have the number 8. That's going to be part of my intersection. They both have the number 10. They both have the number 14 and 16. I think that's all they have in common. So A intersection B prime is going to be 4, 8, 10, 14, and 16. So doing intersections of sets, once you know what the sets are, you just list the sets next to each other, find what they have in common. The next thing is a three-bagger. It's A intersection B intersection C. That's what all three sets simultaneously have in common. So I'm going to write the three sets down. A is the set 4, 6, 8, 10, 12, 14, 16, and 18. B is the set 6, 9, 12, 15, and 18. And C is the set 5, 6, 10, and 15. The only number that's simultaneously in all three sets, if I look at each of the lists that I have here, they all have 6. None of them have no other numbers in all three sets. Like the number 12 is in the top two sets, but it's not in the bottom set. The number 10 is in the first and the third set, but it's not in the bottom set. A intersection B intersection C is just the number 6. It's the number that all three have in common. Intersection means have in common. When I'm intersecting three sets, I need to find out what all three sets have in common. And again, when I do these things pictorially, when I answer the question A intersection B prime, I'm going to get the answer 4, 8, 10, 14, and 16. When I do A intersection B intersection C, I'm going to get 6. I'm not going to get different answers when I answer the questions without looking, when I look at the pictures as when I don't look at the pictures. The last one in this grouping, A intersection B prime, first I find A intersection B and then I do the prime. So to do A intersection B prime, I write the A set down, which is 4, 6, 8, 10, 12, 14, 16, and 18. Then I intersect the B set, which is 6, 9, 12, 15, and 18. Find out what that intersection is, then I do the prime. Intersection is what they have in common. A and B have in common, they both have 6. They both have 12. And they both have 18. So A intersection B, if that's what I was asked to find, is just the numbers 6, 12, and 18. But I need to do the prime of 6, 12, and 18 because I haven't dealt with the prime yet. I've only done the inside of the parentheses first. To do the prime of this set, that's any number that's in the universe other than 6, 12, and 18. The universe contains 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Not that that's readable, but the prime of this is the whole universe other than those, oops, I'm not supposed to delete that. The whole universe other than the numbers 6, 12, and 18. So A intersection B prime is going to be a lot of numbers. A intersection B is 6, 12, and 18. The prime of it is all the numbers in the universe other than 6, 12, and 18. So 4, 5, I'm not going to count 6. 6 is not in the prime of that set. 7, 8 that I crossed out wrong. 9, 10, 11, 12's in the set, so it's not in the prime. 13, 14, 15, 16, 17. I'm not going to include 18 and 19. So the answer to the third one, A intersection B prime, is that set. 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 19. If that was a nuisance and you're good with pictures, then I can get exactly the same answers with my pictures without having to physically list all 4 sets down. So I write my Venn diagram that I need. So I have the set A, the set B, and the set C. The first one wants me to do inside A and outside B. So I want to find the region of the graph that's simultaneously inside the A circle but outside the B circle. Here's the A circle. So I want to be inside that circle, but I have to be outside the B circle. And the B circle is here. Well, it's all this, but I want to be simultaneously inside A and outside B. And that's this same region, this region that I've been looking at when I only have 2 circles. This region is inside of A and outside of B. So I look at the A circle, and I want to discount the part of the A circle that's inside the B circle. And this region right there, even though there's some region that overlaps with C, C has nothing to do with this problem. This region that's inside of A and outside of B, that contains this region right there, that's simultaneously inside of A and outside of B, that contains the numbers 4, 8, 10, 14, and 16 is going to be the region that I want here. So I'm going to say A intersection B prime represents the set 4, 8, 10, 14, and 16. When I look at the answer, then what I got when I did the problem with the sets without looking at pictures, 4, 8, 10, 14, and 16, there's no difference to the strategies. It's just a matter of your comfort level and what you wanna, how you want to attack the problem and how you feel comfortable attacking the problem. The triple intersection is real easy. Triple intersection, I need to be in all 3 circles simultaneously, and that's the region where all 3 circles overlap. So I want to be inside the A circle. So this is so I need to be inside the region of A. So do A intersection B intersection C. I have to be inside the A circle, but I also have to be inside the B circle. And I have to be inside the C circle. The region that's simultaneously inside the 3 circles is that region right there. That region right there, it's in the A circle that I drew, it's in the B circle, and it's in the C circle. And the only number that's in that little region is the number 6. This region right there is the number 6. When I did this, listing the sets, what the sets had in common was the number 6. So A intersection B intersection C is just the number 6. The triple intersection for me is a real easy region of the graph to pick out. The last one, A intersection B prime, again, even though the C circle exists, it doesn't really impact so much the area that I'm trying to designate. So I have my 3 circles, the A, B, C. A intersection B prime wants me to find everything that's outside the A intersection B. The A intersection B is that region where the circles overlap. The prime of that is anything outside those circles, anything outside that overlapping region. So all of those regions, any numbers except the numbers 6, 12, and 18 form A intersection B prime, because A intersection B is 6, 12, and 18. The prime is everything other than that. So it's everything in the universe except 6, 12, and 18. The universe goes from 4 through 19. I'm going to write 4 through 19, but not write 6, 12, and 18. So this is going to be 4, 5, not writing 6, 7, 8, 9, 10, 11, not writing 12, 13, 14, 15, 16, 17, not writing 18, and 19 and 20. And again, you don't have to be able to do problems multiple ways. Whichever way feels most comfortable for you is going to be the way you should do. If you look at the answer that I did, I got exactly the same answer. A intersection B prime is 4, 5, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 19. And I forgot to write 20. Oh, I shouldn't have written 20 on this one because 20 is not in the universe. So scratch out that 20. I can't write a number that's not in the universe, and the last universe had 20 and this didn't, so I kind of messed up. But the answer should be consistent. I think we have more practice with intersections on the next few pages, so hopefully we get good at these. So next problem wants me to create my own Venn diagram and then answer the questions. So the universe here has the numbers 1 through 9. Set A and set B are the only subsets. I'm going to draw a picture to model the sets. I didn't think I gave myself enough room there, so I'm just going to draw the picture nicely. I'm going to draw a rectangle that represents the universe, make a set A and a set B. I need to fill in the numbers 1 through 9. What I fill in first is where the A and the B overlap. A and B both have the numbers 3 and 5. I'm going to put those numbers in first. So I'm drawing the picture of the universe, and I'm starting off by writing the numbers that they have in common, putting them where the circles overlap. So I put 3 in and 5 in, 3 in and 5 in, 3 in and 5 in. Now I want to fill up the rest of the A and the rest of the B circle. A needs to also have the numbers 1, 7, and 9. It has to be in the A circle but not in the overlapping part, so it's going to go there. So I've placed 1, 7, and 9, 1, 7, and 9. Hopefully you pause this and you try to fill in the circles yourself. And if I'm going too fast, stop it, try to work ahead, and then fill in. I'm going to fill in the rest of the B circle. 3 and 5 are in the overlapping region. 2 and 4 need to be in the B circle but not in the overlapping region. And if I look at the numbers I've placed 1, 2, 3, 4, 5, 7, and 9. I haven't placed 6 and 8 for my universe. I'm going to just throw those anywhere that's outside of the circles. So that's a picture for this. If I want to write down what sets are important, A is the set that's given to me, 1, 3, 5, 7, and 9. A prime is going to be any number that's in the universe other than those numbers. A is the odds, so A prime is going to be the evens. It's going to be 2, 4, 6, and 8. B was the set 1, 2, 3, 4, and 5. The universe contains the numbers 1 through 9, so the prime of B is going to contain the 1 that's not in this set and the 6, 7, 8, and 9 that's not in this set. So if I like answering the questions with just looking at the sets and not looking at the picture, then I could write down the sets. If I'm using my pictures only, I don't need to write down the sets. So now if I attack these problems, A intersection B prime, I'll take the A, which is 1, 3, 5, 7, and 9, intersection with B prime, which is 1, 6, 7, 8, and 9. And when I intersect those, what they have in common is they both have 1, they both have 7, and they both have 9. So A intersection B prime is going to be the set that contains 1, 7, and 9. And again, I'll go back and do this pictorially in a minute, and I forgot to write the prime there. The next one on my list is A prime intersection B prime. A prime is 2, 4, 6, and 8. B prime is 1, 6, 7, 8, and 9. Intersecting is what they have in common. I see a 6 and an 8 in both. So A prime intersection B prime is going to be 6 and 8. The answer to the second question, or the second thing in the list there, is 6 and 8. And the last one, A intersection B prime, I do the A intersection B first, and then I do the prime. A intersection B is going to be 1, 3, 5, 7, and 9, which is A. Intersection B, which is 2, 3, 4, and 5. When I intersect A intersection B, they both have 3 in them, and they both have 5 in them. So A intersection B would be just the set that contains 3 and 5, but I want the prime of 3 and 5. Because the numbers in the universe are 1 through 9, the prime is every number except 3 and 5. So I'm going to start writing down the universe. The universe has the numbers 1 and 2. I'm not going to write 3 down because 3 is in A intersection B. To find the prime, it's everything in the universe except that. And then I'm going to write 4. I'm not going to write 5. And then 6, 7, 8, and 9. So those are the answers to the 3 questions that are posed to me. I could get the answer without the pictures like I did there, even though I constructed the pictures. I didn't need the picture to answer the question. If I wanted to answer the questions pictorially, then I need to understand the region that I'm asking for. The first one, A intersection B prime, means inside the A and outside the B. Prime means outside, so I need to find the region of the graph that's simultaneously inside the A circle, outside the B circle, and it's the same again. A lot of these things come over and over again. This is the region that I'm searching for here. A intersection B prime is the region that's inside the A circle, outside the B circle. If I look at the numbers that are inside the A circle but outside the B circle, it's this numbers 1, 7, and 9. 3 and 5 are inside the A circle, which is good, but they're also inside the B circle, so they're not part of B prime. 6 and 8, they're not inside the A circle, so they're not good. I want to find all the numbers that are inside the A circle and outside the B circle. That's just 1, 7, and 9. The next one, A prime intersection B prime, I want to be both outside the A circle and outside the B circle. And that's the region outside the circles. A prime is outside the A circle, B prime is outside the B circle. This region right here has to be outside of both circles. Any of the other parts of the inside, it's inside one or both of the circles. This is I have to be simultaneously outside the A circle and outside of the B circle. That's that region there. And on my graph, the numbers that are outside the A and the B circle are the numbers 6 and 8. So A prime intersection B prime is 6, 8. The last one, A intersection B prime, it means outside the intersection. So if I find the intersection is 3 and 5. Outside the intersection is the rest of the numbers. 1, 2, 4, 6, 7, 8, and 9. So A intersection B prime is anything that's outside the intersection of A and B. The intersection of A and B is 3 and 5. Outside the intersection is any number 1, 2, 4, 6, 7, 8, and 9. So pictorially, it's anything but this. It's anything outside this, oval, I guess it kind of is, football shape figure. So that is 1, 2, 4, 6, 7, 8, and 9. So if we're doing things pictorially, we're just going to have a sense of the region that we're looking for. When you only have 2 sets, it's easier to understand the region that we're looking for, more so than if we're dealing with 3 sets. And anytime I'm asked to find intersections and complements of sets, whether I have or don't have a Venn diagram, I can do the problems without the Venn diagram completely. I'm wearing out, so I got to imagine you are. And there's still a decent amount to go. Another problem that contains asks me to draw a Venn diagram. Hopefully you can take a second and draw this picture. So I made a really small universe. The universe has 3 sets in it. Normally we take those sets and overlap them, and I write an A first, a B second, and a C for my third circle. But it's not crucial that I do that. So maybe take a second, pause the video, try to fill up the circles. I just have to put the numbers 1, 2, 3, 4, and 5 somewhere in these circles, or outside the circles inside a rectangle. First thing I do is find out the very middle. I find the first thing I'm going to plug in is the 3, because the 3 is everywhere. It's in the universe, it's in A, it's in B, and it's in C. And this region in the dead center of all the circles is the region where that 3 goes, because that 3 needs to be in the universe. It needs to be inside the A circle, inside the B circle, and inside the C circle. The next thing I'm going to do is fill in any other overlappings. If I look at the sets, the set A and the set C both have the number 2. So the number 2 needs to simultaneously be in the A circle and the C circle, but it can't be in the B circle. This region right here, off to the left of the 3 that I put in, it's in the A circle, it's in the C circle, but it's outside the B circle. That 3, though, isn't. That's 3's in all the circles. So now I place the 2. 2 is placed, 2 is placed, 2 is placed. Now I have to decide where to put the 1, 4, and 5. And the 1, 4, and 5 need to go inside circles because they're in a set, but they don't need to be in overlapping regions. The number 1 for the A needs to be in the A circle, but it can't be in that region right there. That region of the A circle is part of the B circle. It needs to kind of be free off in the A circle. And the numbers 4 and 5 need to be inside the B circle, but they can't be in any of the overlapping regions because they're not in other sets. So let me write down all the sets that might be interesting in this problem. So I gave the A, which is the numbers 1, 2, and 3. A prime is the rest of the universe. The universe only has 5 numbers. The prime of A is going to contain the rest of the universe, 4 and 5. I actually asked for this down there, so I'll write it down there. B is the set that contains 3, 4, and 5. The prime of B is going to be the rest of the universe. The rest of the universe is just 1 and 2. The numbers 1, 2, 3, 4, and 5 are in the universe. The rest of B makes up B prime, which is 1 and 2. And then C is the set 2 and 3. If it's necessary, C prime, as it has the rest of the universe, it's going to have 1, not 2 and 3, but 4 and 5. So the universe for this particular problem only has the numbers 1 through 5, which makes it easier to deal with. I drew a picture that I can construct the sets. The A has 1, 2, and 3. C has 2 and 3. B has 3, 4, and 5. There isn't any number that's outside of the universe. Every element of the universe is in one of the sets. I'm asked here to do A prime intersection C. So I'll write down what A prime is. A prime is the set 4, 5. If I want to intersect that with C, C is the set 2, 3. Intersects what they have in common. There's nothing in common between those sets. So the answer to this intersection is empty set because there's nothing in common. You can write it with a 0 with a line through it. That means there's nothing that's in common between those two sets. Or you can write set brackets with nothing between them. That means there's nothing that's in both sets A and C. A prime and C. There's definitely things in both A and C, but A prime is just the numbers 4 and 5. Outside the A circle, the numbers 4 and 5. Inside the C circle is 2 and 3. There's nothing in common. The next one is A intersection B prime intersection C. It's what those three sets have in common. A is the set 1, 2, and 3. B prime is the sets 1 and 2. And C is the set 2 and 3. So just from my listings, A was 1, 2, and 3. B prime was 1 and 2. C is 1, 4, and 5. When I intersect sets, what they have in common, if I look at the three sets, A, B prime, and C, what they have in common is just the number 2. So the answer to the intersection of A, B prime, and C is just the number 2. And the last one I'm going to do here is A intersection B prime. First I'm going to find out what A intersection B is, and then I'll do the prime. A is 1, 2, and 3. B is 3, 4, and 5. The intersection of those two sets is the number 3. That's the only thing A and B have in common. That's the A intersection B part. Now I want to do the prime. The prime of a set is every number in the universe that's not in that set. The universe are the numbers 1 through 5. This set just has 3. The prime of that is the whole universe except for 3. So 1, 2, 4, and 5. So those are the answers to the interesting parts. A prime intersection C, A intersection B prime intersection C, and A intersection B prime. Let me try to do all of those again with just looking at the pictures. I'm not going to get any different answers, but maybe I'll do something that makes more sense to you if you're not into writing down the sets. So the first one wants me to do A prime intersection C. That means inside the A circle, outside the A circle. So I'm going to be outside the A, and I want to be inside the C. So when I look at A prime intersection C, I understand what that means. It means I want to be outside of the A circle, but inside the C circle. It's going to be this region right here. This region is inside the C circle, because the C circle is all this circle here, but I want to be outside the A circle, and this region right here of the C circle is inside the A circle. So I want this region to be inside the A circle and outside the C circle. The prime means outside of the circle, non-prime means inside the circle. That's the region that's simultaneously inside of C and outside of A. If I look at my picture, it means this region right here. And if I look at the contents of that region, I don't see any numbers. That's why I said this is the empty set. The next one gets to be a little bit cumbersome, working with the pictures. But it's not impossible to do working with the pictures if you're visually gifted. So it says inside A, and, I read that intersection as and, I have to be outside of B, and I have to be inside of C. So again, if you're really visually gifted, you can get this answer quickly because you understand the region that it's looking for. So I want to be inside of A. So inside of A, this is the A circle. I have to be inside of A. But now I need to be outside of B, so I can't include this little region right here because this little region is inside of B. So immediately, if I'm just looking at these two regions right there, the region that's simultaneously inside of A and outside of B, because I need that, is this region. So that's if I was just considering A intersection B prime. But now I also have to be inside of C. And to be inside of C, I need to be in the C circle. This is my C circle. In the region that is inside of A, outside of B, and inside of C. So both inside A and C, but outside of B, is that region right there. That region, it's in the A circle, it's in the C circle, and it's outside the B circle. And that's simultaneously inside A, inside B, and outside C. If I look at my picture, the picture gives me this region right here is what I'm looking at. It's not counting the overlapping. This is a picture, this number right here, that number 2, that's hardly readable. It's outside the B circle because the B circle stops there at that 3. It's inside the A circle, and it's inside the C circle, so that is just the 2. So the answer to this is just that 2. And now the last one of these, A intersection B complement. I find A intersection B, and then I complement, and this is easy for me. The C, although it's drawn, it doesn't impact the area that I'm looking for too terribly much. So I have the A, the B, and the C circle. This is A intersection B. but I want the complement of A intersection B, so I want anything that's not there. So anything in this picture that's not in the overlapping of A intersection C, B should I say, is going to count. So if I just cross out that region, A intersection B, what's left? The 1, 2, 4, and 5 is in the complement. So this region right there is A intersection B. The complement is the rest of the universe, the rest of the picture. If I cross out A intersection B, what I haven't crossed out is the complement, which is 1, 2, 4, and 5. So the answer to A intersection B complement is this region out there. It's everything but 1, 2, 4, and 5. Intersections and primes for me are the intuitive, easy set operations. There isn't necessarily a hard set operation in terms of there isn't algebra to do. We're not solving for x. But the next concept, for some reason, is just, I don't know, trickier for students. And that concept is the concept of union. And union is making bigger sets. So intersection is what they have in common. Complement is the rest of the universe. But union isn't anything in one set or the other set. We've dealt with these sets already, and so I'm going to write down the sets again. And hopefully you have these handy. Here, A is the set 1, 3, 5, 7, and 9. A prime is the rest of the universe. The universe had the numbers from 1 through 10. A was the evens. A primes are the, or A was the even. A prime is the odd. A is the odds. A prime is the even. B were the numbers 6 through 10. B prime are going to be the numbers from 1 through 5. Again, if I'm going spastically fast, you can pause, hopefully, and get caught up. So I haven't done anything new here. I've just listed all the sets that might be appropriate for this universe. I'm not even writing the U because I don't really need to have the U written down for me to do these. The symbol A union B means any element that's in the A circle or the B circle, or in simultaneously both circles. To write down what A union B is, A union B, I write down the entire A set, which is the set 1, 3, 5, 7, and 9. So that's the entire A set. A is 1, 3, 5, 7, and 9. B is the set 1, 2, 3, 4, and 5. A union B is the sets made together into a bigger set. It's all of A and then anything in B that I haven't already listed. So I've listed all of A. I've already listed 1. I'm not going to list it again in the union. I've already listed 3 and I've already listed 5. So A and B is the set that takes all the elements of A and then anything in B that I haven't already included with A. A is 1, 3, 5, 7, and 9. I've already included the 1, the 3, and the 5. Inside the union of A and B, I need to have the number 2 as well and the number 4 as well. A union B is going to be the set containing 1, 2, 3, 4, 5, 7, and 9. It's any element that's in A or in B or in both. 1's in both, so it's in the union. I don't write it twice, even though it's written in 1. 2's in B, so it's part of the union. 3's in A, so it's in both, so it's part of the union. 4's in B alone, it's part of the union. 5's in both, it's part of the union. 6 isn't in A, it isn't in B, so it's not part of the union. 7's in A, so it's part of the union. 8 is let me pretend that I didn't just do that. So if you're watching the video, you're understanding that I just made a horrible mistake because I didn't write the right B down. So hopefully I didn't do a spastically horrible thing and mess you up. My answer is going to be wrong here because to do A union B, I need the A set, which is 1, 3, 5, 7, and 9. And I need to add to that the B set, which is 6, 7, 8, 9, and 10. I wrote the wrong B set down. I wrote B prime down because I just didn't see the prime. A union B is the A set, which is every element in the A set, which is 1, 3, 5, 7, and 9. And then I'm going to add to this set and make a bigger set. Unions are bigger sets. I'm going to add anything I haven't already included. So for B, A union B needs to have a 6. I don't already have a 6. I'm going to insert it in. A union B needs to have a 7. I already have the 7 there. I'm not going to write it again. A union B needs to have an 8. I haven't written an 8. I'm going to write it. A union B needs to have a 9. I've already written it. I'm not going to write it again. A union B needs to have a 10. I haven't written it, so I'm going to write it again. So to form a union of two sets, I write the entire left set, and then I go through the right set, and anything that I haven't already written that's in this set, I include. So union means in one set or both sets. So in A, in B, or in both. The numbers that are in A, in B, or in both A and B are 1, 3, 5, 6, 7, 8, 9, and 10. The numbers 2 and 4 aren't in A, or they're not in B, or they're not in both. So A, that's not going to be part of A union B. So union means in one set or the other set or both. So A union B is 1, 3, 5, 6, 7, 8, and 10. To do A union B prime, that's what I started doing here. To do A union B prime, I take the set A, which is 1, 3, 5, 7, and 9, and I add to it anything that B prime has different from it. And B prime is 1, 2, 3, 4, and 5. So I'm going to take the set A. To do A union B prime, A has 1, 3, and I'm leaving myself room in case I need to fill in, 5, 7, and 9. So A union B prime, I have all of A, and then I go to B prime. And anything I don't have in this list, I need to add to it. B prime has 1 in it, but I already have it. I don't need to write it again. B prime has 2. I haven't written 2. I'm going to write it in. B prime has 3. I already have 3. I'm not going to write it again. B prime has 4. I haven't written it. I'm going to write it again. B prime has nothing else. If I wrote, well, it has 5, but I've already written the 5, and this is a squiggly bracket here. So B prime is 1, 2, 3, 4, and 5. You can see the 1, the 2, the 3. You can see B prime, and I can see A, 1, 3, 5, 7, and 9. So it's a set, it's a bigger set. All the elements of A, and then you add on all the elements of B prime that I haven't already dealt with. Pictorially, it's both pictures combined. So if I want to find A union B, it's any number that's in the A circle, in the B circle, or in both the A and the B circle. So if I wanted to show the pictorial representation of A union B, it's anything that's in either the A circle, the B circle, or the overlapping section of the circles. So pictorially, A union B is anything that's in either circle. So pictorially, any number that's in the A circle or in the B circle or in both are part of A union B. So that's everything except 2 and 4. Every number between in the universe is the numbers 1 through 10, everything but 2 and 4 is part of A union B. If you look at my A union B here, you'll notice that the 2 is missing and the 4 is missing because A union B is everything in the universe that's in the A circle or in the B circle or both, and that's everything but 2 and 4 because the only thing that's outside a circle is 2 and 4. So A union B is just the numbers 2 and 4. The next one means anything in the A circle or outside the B circle. So pictorially, the things that I'm looking for in A union B prime is anything that's inside the A circle, which overlaps some of the B circle, and then again anything outside the B circle. B prime is anything outside the B circle. So A union B prime is everything except these numbers right here. So whatever numbers are in this little region are the numbers I'm not including because I want anything in the A circle or outside the B circle or both inside the A circle and outside the B circle. So A union B prime is anything but that region. That region right there is inside the A circle, inside the B circle, outside the B circle. So it's anything that's in the A circle or outside the B circle or both. That's anything but this. If I look at what I'm excluding 6, 8, and 10, and I'm including this 1, 2, 3, 4, 5, 7, and 9. So it should be 1, 2, 3, 4, 5, 7, and 9. Anything but 6, 8, and 10. So pictorially, for me, unions are harder pictorially. Intersections, even though I'm not that gifted visually, I can do via pictures. Unions, I have a heck of a time doing with pictures. I'm just not that gifted visually. I can kind of explain it because I've done it long enough. But when I was learning this, I would never do a union pictorially because it just doesn't do it for me. So union is anything in one set, the other set are both. Pictorially, all of A, so I needed the entire A circle. So all of this needed to be included. And then anything outside the B circle needed to be included, and the only things that weren't included are the stuff that was inside the B circle, outside the A circle, everything but the numbers 6, 8, and 10. So these are a little bit tougher, and tougher whether you're doing with or without pictures. So I'll try to do them both ways to see how we do, how I can do. Keep peeking over to make sure my video doesn't end because these videos only go for so long, and I hate to be just talking to myself even without being videotaped. That would be absurd. So for this set right here, I need to know what all the sets are if I'm doing it without my pictures. The numbers here are from 4 through 19. A contained the evens 4, 6, 8, 10, 12, 14, 16, and 18. We've done these already, so hopefully you have them listed and you don't have to recreate them again. A primes are the odds, which are 5, 7, 9, 11, 13, 15, 17, and 19. B's were the multiples of 3 in this set, which were 6, 12, 6, 9, 12, 15, and 18. C is B prime is the rest of the numbers between 4 and 19 that I haven't listed. So 4, 5, yes, 6, no, 7, 8, yes, 9, no, 10, 11, yes, 12, no, 13, 14, yes, 15, no, 16, 17, yes, 18, no, and 19. So B prime is 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and 19. C was a short set that had 5, 6, 10, and 15, and C prime's going to be long then. C prime's going to have 4, not 5 and 6. It'll have 7, 8, and 9, not 10, 11, 12, 13, and 14, not 15, and 16, 17, 18, and 19. Now these are going to be a nuisance to do. So A union C, I take the entire A set and then add to it anything in the C set that I haven't gotten already. So the A set is 4, 6. I'll leave myself room just in case I need to fill things in. 8, 10, 12, 14. I didn't leave a lot of room there. 16 and 18. So all I've put down in my union is the entire A set. So the A set is in my union. I need everything in the A set, which is 4, 6, 8, 10, 12, 14, 16, and 18. And now I'm going to start adding things from the C set. I go to the C set. The first thing I see in the C set is 5. I don't have it in my union, so I'm going to insert it in my union. I look at 6. 6 is in the union. I'm not going to add it again. 10 is in the union. I'm not going to add it again. 15 needs to be in there. I'm going to add it. So the numbers that go in A union C are all of A, 4, 6, 8, 10, 12, 14, 16, and 18, which I just wrote the A down. I left myself probably bizarre room, but I left myself enough room to add the C. Then I went to the C. I looked at my list. 5 needed to be added because it wasn't already in my list. 6 was already there. I didn't add it. 10 was already there. I didn't add it. And 15, and I added it. So A union C is 4, 5, 6, 8, 10, 12, 14, 15, 16, and 18. A union B union C, I start down, I write down all of the A. So A is 4, 6, 8, 10, 12, 14, 16, and 18. That's the beginnings of A union B union C because that's A. Now I'm going to go to B and add anything I don't already have on the list. So I'm looking at B. B has 6. 6 is already there. I don't need to write it. Next thing in B is 9. It's not already in there. I'm going to write it in. Now I may put some commas between those. Next thing in B is 12. It's already in the list. I don't need to add it. Next thing in B is 15. It's not in the list, so I need to add it. Last thing in B is 18. It's in my list. I don't need to add it. So I have all of A in.